We are going to move right along in our functions topic. Today we're going to talk about identifying functions. So everything we've been doing up until this point is leading us to this moment. We talked about relations, which are when we have a mapping of an input to output. But if that input to output works in a certain way, that relation also is a function. So we're going to talk about that a little bit, dive into it, and then identify from ordered pairs, mapping diagrams, graphs, and tables whether or not a relation we see is a function. So we're going to get started right away. Remember, if you would like to download the PDF of this lesson, it is in the details below, whether you would want it electronically or to download and print. Okay? So let's start with identifying functions. For your information, we're going to define what a function is. So a function is a relationship where every input, remember input is our domain, it is like our x values. So in parentheses, I'm going to put x there to make that correlation that input is our x values. Every input corresponds to exactly one output. Oops. Okay, that's our y values. So when we're looking at different relations given in different ways, whether it's an ordered pair, a graph, a table, a mapping diagram, there's different little things we can look out for in each of those ways that will easily help us point out whether or not the relation we're working with is or is not a function. So the first thing we have is when we have ordered pairs or a table. So remember, what we're saying a function is that every x corresponds to exactly one y, meaning that no x repeats, essentially. So when we're looking at ordered pairs or a table, we're looking to see that no x value repeats. We want to see each x value one time and one time only. If we see an x value more than once, then right off the bat we know that relation is not a function, because that would mean that an x value is mapping to more than one y values. And our definition says each x goes to exactly one y. I always describe it in class. Your names on the roster map to one unique person. There is no name on my roster that people come in and say, that is my exact first, middle, last name, identical. There's no two people that share that, right? So each of our inputs, each of our names on our roster go to one unique person when they walk into my classroom. When we're looking at graphs, we can easily tell if it is a function by using this test called the vertical line test. So if your graph passes the vertical line test, then yeah, you have a graph of a function. And if your graph does not pass the vertical line test, then no, you don't have the graph of a function. And I'm going to try to draw two little images here. I'll draw a graph going this way, and I'll draw a graph going this way. And as you see here, the graph on the right that I just drew my vertical line through, it passes through, that vertical line passes through that graph more than one time. So therefore, this does not pass the vertical line test, so this is not a function. I like to call it a lot of times like the pencil test. So what I'll do is I'll take a pencil and I'll put it on the board and I'll trace it from left to right. And I say, okay, tell me, does this pencil, or I'll do exactly what I'm doing, does this vertical line pass through as you transfer that vertical line left to right? Does it pass through that graph at each of those points in one time and one time only? And it does. No matter where I move this vertical line, it passes through my graph one time and one time only. So this would be an example of a function, because no matter where I draw that vertical line, it's only ever going to cross that aqua blue graph one time and one time only. The next graph, where I draw that vertical line, it passes more than once. Fails vertical line test, therefore not a function. Okay? And then last but not least, we have our mapping diagrams. I like determining if mapping diagrams are functions. It's another easy way to by just looking at the input. I do not care about the output whatsoever. All the outputs can repeat. They can all be 5. They can all be 7. They can have multiple inputs with that same output, but the inputs have to be unique. And so what we're looking at is that each of the inputs, the X, have one line to an output. So if I see an input, an X, have more than one line coming out of it going to the output, then I do not have a function. But if I skim those inputs in my mapping diagram and each of those inputs have one line, then yeah, that is a relation. That's also a function. So with that understanding, we're going to dive right into it. We'll look at these first two. We're going to go A, C, and then we'll go B, D, E, just so I can work from left to right here. So the first one, we have an ordered pair. So remember, we don't really care about the y's, we care about x. And we want to see if any of those x values repeat. So I'll even zoom in here. Okay, and we see, if I'm looking at them, I see 2, -5, 2, and 0. So I see that the 2 repeats, right? I see it 2, 3, and I see 2, 7. Therefore, this is not a function. And the reason why, the justification would be the input, x equals 2, repeats, you can say, or shows up more than once, or maps to 2 y's, because the definition of a function is each input maps to exactly 1 y. So by identifying that an input maps to more than 1 y, then we're showing, okay, yep, can't be a function. Okay? Moving over here, looking at letter C, we have a mapping diagram. So to determine if this is a function, we only care about the input. I'm not even going to look at the output and the arrows that each of those y values are receiving. I'm going to look at the -5. Does that have one line coming out of it? Yes. I'm going to look at the -3. Does that have one line coming out of it? Yes. I'm going to look at the next guy, +3. Does that have one line coming out of it? And the answer is no. It has this one and this one. So I'm not going to go any further. I see that this value of 3 is mapping to both the 0 and the 2, right? So I see that the input is mapping to 2 outputs. So therefore, because of x equals 3 maps to 2 values, this relation is not a function. So I'm going to write that here. Not a function. The input x equals 3 maps to 2 outputs. You could also say that the input repeats, that it goes to 2 different y's, something along those lines. Okay? All right. Moving right along, we have a table. So I gave you one of everything here, so you can be exposed to all of them. So looking at this table, once again, we're only looking at the x. I do not care what's happening in the y. I only care to see if the x values repeat. And hopefully you see right off the bat that that -3 repeats. -3 is mapping to 0, and -3 is mapping to 2. So this, once again, is not a function. And the reason or the justification is that you know the, whoops, how did that happen? The input, x equals -3 maps, goes to, has two outputs. And we understand the definition of a function. Each input has to map to exactly one output. So see, -3 is mapping to more than one output. It's going to 0, and it's also going to 2. Okay? Letter D, we have a graph of just plotted points. So once again, you can list all of these as ordered pairs if you're more comfortable with that. And then you can look at each of the ordered pairs and say, okay, do any of the x values repeat? Or you can use this vertical line test. So what I'm going to do is I'm going to draw a vertical line at the first ordered pair, and I'm going to make it really, really long. Okay? And I'm going to say, okay, if I have that vertical line there, is there only one point that passes through the vertical line? And the answer is yes. So far we're passing the vertical line test. Then I'm going to go to the next ordered pair I see. And I'm going to say, okay, if I draw another vertical line, does only one point pass through that vertical line? And the answer is yes. Then I'm going to go to the next one. And I'm going to draw another vertical line. And I'm going to say, okay, if I draw that vertical line, does it only pass through one point? And hopefully you're saying no. It passes through this ordered pair, 1, 1, and it passes through this ordered pair, 1, -3. So we see that we have an input of 1 mapping to two outputs, +1 and -3. And so it fails that vertical line test, and therefore it's not a function. So this would be not a function. You could state that it fails, and I like to abbreviate vertical line test. You could also state that x equals 1 maps to two outputs, or something along those lines. X equals 1 has two y values, something like that. So fails the vertical line test. So we have not gotten lucky here. Everything I showed you so far is not a function. And let's move on to our last guy. Let's see if I can zoom this in here and zoom up. All right, so I'm going to draw one vertical line, and I'm going to make sure it's really nice and straight. I'm going to let it autocorrect. There we go. And I'm going to do my pencil test. So this is a graph of a continuous line. There's not just ordered pairs, it's actually a line or a curve. And so to see if it passes the vertical line test, I'm going to take my vertical line and I'm going to move it, or you can take your pencil and move it, and I'm going to say, okay, as I move left to right with this vertical line, is it only ever intersecting with that black line one time? And so far it is. Wherever I draw my vertical line, it's only ever crossing one time, right? Even right there, it's really only crossing one time, right? One time. One time. No matter where you draw that vertical line on that graph, it's only ever intersecting your relation one time. And because of that, that tells us, okay, it passes the vertical line test, so it is a function. And to justify, you could say that it passes the vertical line test. I would actually spell out vertical line test if it was a test, a standardized test or something like that. Or you can even say what the definition of a function is. Every input goes, maps, is paired with one unique output. and you can recite your understanding of what a function is. We know by definition if something passes the vertical line test, it is a function, so that should suffice as well. Okay? So those are our 5 different ways in which we can see relations, right? And then determine if those relations are functions. So just a little wrap up, a little summary, some helpful hints that in order for any relation to be a function, each x value must appear one time and one time only. Basically, no x value repeats, okay? When we have graphs, we use something called the vertical line test to determine whether a graph is or is not a function. And when you are looking at these things, we don't even pay attention to the y values. Do not ever focus on the y value. That will not tell you whether or not something is a function. All we care about is the input for determining whether or not something is a function. Okay? So you will see that I've given you 5 problems as a U-Try, so you can identify if you need some extra practice. You can look through those to see if you need any help. And then, as always, I have a video in the details below if you would like to watch the video for some extra coaching through the U-Tries, or if you need an explanation because something you got doesn't seem right. I do also attach an answer key for you to do a quick glance and check your work there. Hopefully this helps you identifying functions. The more you do it, the better you become at it. So just really making sure that you're focusing on the x, and you remember that no x value can repeat. We want each unique x. So if you got that down, you will be able to spot a function pretty easily. So thank you for your hard work. Thanks for tuning in. Keep watching these videos for helping you on your math journey. Like, comment, subscribe, all those great things so I can keep making awesome content for you. Have a great day.